continue our talk with Le Chatelier's principle, but now we're going to talk about the second stress that could occur. So the second stress, we talked about concentration in the last video. Now we're going to talk about temperature. Now one thing I want you to be careful of, temperature is the only thing that can actually change the KEQ. So in the end, we're also going to have to figure out how the K would change. So keep that in mind. Anytime you change concentration or pressure, K is constant. But anytime you change the temperature, K can change. So make sure that you're very careful to remember that. Now, both these reactions are exothermic or endothermic. So if we look at this first reaction, we can see that heat is being produced. That means it's being released, it's being made, it's being formed. This reaction is exothermic. Whereas we look at this one, heat is being absorbed. It's required in order for the reaction to take place. This is an endothermic reaction. So would you agree, as we increase temperature, would you agree that we are increasing heat into the system? How does something increase the temperature? By adding heat to it. So when you are increasing temperature, you're going to treat it the same way we did concentration changes. But you are going to look at heat as a product or reactant. And I'll always give that to you. Or I might say off to the side, for this one, delta H equals a negative number. You would need to know negative delta H means it's a product. So you might have to put the delta H in yourself. But I will give you if it's exothermic or endothermic. You're just going to need to remember if that means it's a product or reactant. So exothermic means that heat's a product. Endothermic means that heat is a reactant. So we're actually going to do this the exact same way we did concentration, but we're going to treat heat as the actual product or reactant that we're changing. So let's do this first reaction again. What happens when you increase the temperature? So I'm going to put the stress in red just like I did in the last video. So we are increasing heat. So here's our stress. We're increasing that. So let me grab my ruler. So you grab your pencils and you guys practice this. If we increase heat, that means that this is going to be pushed down. Why? Because we're adding more over here. It weighs more. It's going to push it down. So you see, now we're out of equilibrium. This side's too high. Just like talking about concentration in the last video, the shift is going to be the side that we have to push down in order to get it back to normal. So we have to push down the left side. So in this case, the shift would be to the left. How would we get this? So if it looks like this, how would we get this to go down? We'd have to increase N2 and H2 to make it weigh more. We'd have to increase this. So that means, as a result, and I'm putting the results in blue, as a result, these would increase. Look, if we increase the product side, as a result, the reactant side is going to increase. Always do the exact same thing to the opposite side of the reaction. So N2, concentration of N2, and concentration of H2 would increase. Now we have to talk about NH3 right here. So if we look, we added heat. What's going to happen to get this back up? We'd have to take this away. This weighs too much now. It needs to weigh less. So we take it away. That would mean this is decreasing. So NH3 would decrease. Now we do have to talk about K. Now there's a slight difference between academic and honors. K, you would just need to know that K changes. You would not need to tell me exactly how it changes. You would just need to know, since temperature changes, since the temperature is changing, K is no longer constant. K has changed. Now, honors folks, you're going to need to tell me exactly how K has changed. So we're going to use our little generic, kind of oversimplified KEQ expression. K equals products over reactants. Let's see what has happened here. When we increase the heat, as a result, the reactants increased, the products decreased. What would that make K do? If the products are decreasing and the reactants are increasing, wouldn't you see products on top? Wouldn't that make K decrease? So the answer would be that K decreases. Whatever is happening to the products as a result of your shift, so in blue, whatever happens to the products in blue, that's going to be what happens to K, because products are on the top of our KEQ expression. Now I want you to notice something, because I'm one to notice patterns, and there is a pattern here. The shift is what the problem told us to do. Look at the opposite side of the reaction. Look, the exact same thing is happening on the opposite side. And look at the same side as the stress. The opposite thing is happening to the same side. So same thing is happening to the opposite side as the stress. The opposite thing is happening to the same side. Now some people are like, oh my goodness, that's way too many opposites and sames. But that's how I think of it. So if you really like the method of doing the seesaw, that's really cool. That will work for you. But there is a very definite pattern. The shift is always away from an increase. Here's an increase, we shifted it away. It shifts to the left. That means everything on the left side is increasing as a result of that shift. And then everything to the right is decreasing. That's what that shift means. So whatever you need to do to figure out how to get these right every time, but I'm telling you, there is a very distinct pattern. It is not random. I'm doing the same thing every time. You just need to let your brain click exactly what I'm doing. I'm going to do 2 more examples with you using this new equation. So we've got SO3 plus heat. So now our heat is here. And it says we're going to increase the temperature. That's equivalent to adding heat to the system. So there's our stress. We're going to increase this. Let's look at the ruler. As we increase the heat, that's the reactant side. That means this is going to go down. Do you see the side we have to push down as a result? The side you have to push down is the side that we're shifting. So it's going to shift it to the right. That means everything on this side has to increase in order to get that to push down. So SO2 and O2 are going to increase. Whereas SO3, in order to get this down and this back up, we're going to have to decrease this side because this side's too heavy right now. We have to cause it to be lighter, so this side needs to decrease. SO3 will decrease. Now we do have to talk about what happens to K for honors folks. Academic folks, you would need to know that K changes. So if it ever says what happens to K, you would need to say changes. But honors, you need to tell me exactly how. So let's look and see what has happened to the products. The products have increased. If the products have increased, do you see how that would also increase K? So in this case, K increases. Okay, I'm going to erase my work. So now you can see yet one more example of temperature. So if we decrease the temperature, now in reality, every single answer is going to be exact opposite of what we already did. But let's use this to figure it out. If we decrease the temperature, that's going to cause this side is decreasing. It's going to cause it to go up. So the side that you shift is the side you have to push back down. We have to push this side back down. That's a shift to the left. Okay, so let's think about it. If we have to push this back down, what's going to happen to SO3? This side is too light. We got rid of this. Oh no. Now we need to add SO3 to get that back to where it was. So SO3 would need to increase, and SO2 would need to decrease. So I'll show you the teeter-totter. If heat decreases, it's going to look like this. In order to get this side to go back up, we're going to have to take some of this away. So decrease it. If you look, Here's what we did to the reactant side as a stress. The products are all going to do the same thing as the stress on the opposite side. Whereas the thing right next to it is going to do the opposite thing. So if we decreased reactants as a stress, we've got to decrease products and increase reactants. So shift left, and then SO2 and O2. Will decrease, and SO3 will increase. Notice this is the exact opposite of the problem right here. The exact opposite of the one right before. Let's look at what happens to K. Again, academic folks, you would just need to know that K changes because we changed the temperature. But honors folks, we just decreased the reactants and we decreased the products. Yeah, I felt like something was wrong with what I said. Decrease the products, we increase the reactants. Do you see how that would make K decrease? So whatever we do, whatever happens to the products as a result of the shift will be whatever happens to K. So there you have it. That's how you figure out how temperature changes are going to affect systems in equilibrium.